Hello everyone, in this video we are going to derive the equation for the hoop strain. Okay, so in order to know this, you of course need to know about the hoop stress, and take a look at this portion. I know we always know that stress is proportional to strain, so sigma is proportional to the strain, that is E, small e. So sigma equals to modulus of elasticity, that is denoted by capital E. This is the modulus of elasticity into small e, and then you get a small e equals to sigma divided by capital E, that is the modulus of elasticity. So after that, hoop strain is also known as circumferential strain, and this hoop strain will bring some changes into the diameter. How? Let me uh, take this picture in front of you to understand more clearly. So you can see that because of the hoop stress, the walls of the cylinders are hooping outwards. So there will be change in the diameter. So as there is going to be change in the diameter, there will be of course some changes in the lengths as well, right? The length will decrease if the diameter will increase. So for that, because of that reason, you need to subtract this part, that is the delta L over capital delta sigma L divided by m into E. So this is this part. Let me make it more clear to you. You can see that this part, okay, sigma L over E. This is the this is the equation for the longitudinal strain will be, right. So because of this will find how much the decrease in the length has occurred there. So and it you have to multiply mu with this, and this is the Poisson's ratio mu. This is 1 by m, this is same, and Poisson's ratio, and there will be no unit of this because this is just a ratio. So after that, you know that delta H is equals to PD over 2T, and I have derived this equation as well as delta sigma L equal to PD by 40 in the previous two videos. So you can see it, check it out from there. So this is the value, and I have just substituted to get this equation. Okay, so here you can write it like this as well. PD divided by 2T capital A, 1 minus, so 1 by 2 into m. So 1 by m will become mu. 1 by m will become mu. So you will be left with mu by 2. So you can replace it like this if you wish. And after that, we are going to learn about the longitudinal strain. So we are going to learn about longitudinal strain. So same logic applies here. The strain is going to be stress. The strain is going to be your stress over modulus of elasticity, right? Stress over modulus of elasticity. This is going to be the logic for this if you want to find the longitudinal strain. So this is of course the change in length divided by small l, because the longitudinal strain will bring changes into the length, as we have seen earlier. This will make some changes in the length. So as the length will increase, of course the diameter will decrease, because we are not adding any material from outside. We externally were not adding any material, so we have to subtract it like this. Let me make it more clear to you, just in case. So yes, so you will find this circumferential stress into 1 by m. So you can write it like this as well: sigma L over E minus mu times sigma c divided by E. So sigma c is same as sigma h. Both are circumferential stress or the hoop stress. Okay. So after that, you have nothing to do except substituting the values for sigma h and sigma t, and you will get it. And you also need to remember that 1 by m is equals to mu. That is also Poisson's ratio, and it's having no unit in it. So after that, we will be moving forward to learn about the volumetric strain. So now we will learn about volumetric strain, that I will denote with E EV. Okay, this is the EV. Okay, let me write it more clearly. This is the volumetric strain that we are going to find now. So for that, we have already known about the circumferential strain. We have already known about the longitudinal strain. Circumferential strain is also your hoop strain, right? And whenever you are seeing E, you need to understand that this is strain, and sigma, this is of course the stress. So you know, for a cylinder, the volume will be pi r square into h. This is the volume for a cylinder that is having the height h and the radius of the cylinder is small r, right? So you know that. and we have just used that formula here over here for finding the volume equal to pi by 4. How? Because we know that d diameter is going to be 2 times r. So if you just substitute that, you will find pi by 4 d square times L, because L is the length of this cylinder. Now differentiating throughout, we can get said, if you differentiate throughout V, then you'll get delta V, this V, because we are differentiating it partially, right? So after that, pi by 4 d square, and pi by 4 will remain, d square will remain, and you will get delta L plus, and now you will keep L constant and you will differentiate d. So pi by 4 into L, so you keep yes, so 2d into delta d. So after that, you just substitute it, pi by 4 d square into delta L, into, you intentionally take L by L, and then pi by 4 times pi by 4 times L into 2d into delta d, into, you intentionally take d by d. This has been taken intentionally to uh, you know notice here why I have taken L by L, because when you take L by L, if you just write it like this, delta L by L, and here delta d by d, then you will notice that this part over here is your EL and this part is your EC. Okay, so then you will get pi, if you just take common here, pi by 4 delta is d square into L. If you just take common here, so delta L by L, what is this? Delta L by L, this is your EL, and delta D divided by D, this is your EC, or this can be written as EH. Okay, don't get confused in between them. So after that, you have found that delta V is equals to V, because this term entirely, take a look at this, pi by 4 into d square into L, this is your V equal to pi r square into h, sorry, yes, because of a cylinder that is having h length, it will be pi r square into small h, and if the cylinder is having length small l, then it will be small l, but here the length is capital L, they have denoted it like this, so you just need to write it like this. So you end up getting the value for the change in the volume. Okay, so now if you just bring this down there, so delta V by V, this is your EV, and this is your EL plus 2 EC. EL plus 2 EC. And here EL is the longitudinal strain, and EC is the hoop strain or circumferential strain.